So the second tool of uncertainty management would be certainty factor here, right? So what is certainty factor? Certainty factor is a theory. It is a popular alternative to Bayesian reasoning, whereby we use CF, a number, to measure the expert belief here. Okay, so the maximum value of the certainty factor is +1, where we define is as definitely true, and the minimum is negative 1.0, that is definitely false. So basically this one has been learned in ISP 542. Now is the revision time for it. So this is the uncertain terms and their interpretation in my sim, but this one would not be asked in final year. So in expert system with certainty factor, the knowledge base consists of set of rule as well, having the same syntax. That is, if of taking evidence, then is the hypothesis, whereby we are going to calculate the CF. CF will represent the belief in hypothesis H given that evidence E has occurred. So certainty factor theory is based on two functions, measure of belief and also measure of disbelief. So in the value of both measure of belief and measure of disbelief range between 0 and 1 here. So for example, we take a look at a simple rule here. If A is X, then B is Y. So an expert may not be absolutely certain that this rule holds. Also, it has been observed that in some cases, even when in the if part rule is satisfied, object A takes on the value X, object B can acquire some different value on value Z. For example, if A is X, then B is Y with CF 0.7, but B is Z with another value that is 0.2. So for example, we consider CFHE is equal to CF evidence times CF. So example is the sky is clear, okay, then the forecast is sunny with CF 0.8, and the current certainty factor is the sky is clear is 0.5. So for example, here is 0.5. So what about our CF here? CF of the hypothesis would be, okay, 0.5 times 0.8, that is equal to 0.4. 0.4 can be interpreted to maybe, meaning that the certainty of the forecast of sunny would be it may be sunny. So if we have conjunctive rule such as evident E1 and another evident E2, and then we have up till En, so we have the hypothesis with the CF value. So how are we going to establish the CF value is by using the minimum. Okay, so for example, here we have a sky is clear and the forecast is sunny, then action is wear sunglass with CF 0.8. So given that the sky is clear is 0.9 and the certainty of forecast is sunny is 0.7, so how are we going to calculate the CF for this rule would be minimum of this evidence, okay, times the value of CF of the consequence, that is 0.8. So from here, from these two, we know that the minimum value would be 0.7 times, to have the CF would be times 0.8, that is equal to 0.56. If we have a disjunctive rule with OR logic here, previously we have N. If OR, we are going to have maximum. So for example, here with the same rule, we have here is 0.6 and this one is 0.8. What would be the maximum value here? Maximum is 0.8. times 0.9, you will have 0.72. When the same consequence is obtained as a result of the execution of two or more rules, right, the individual certainty factor of this rule must be merged using another formula. So if we have only this hypothesis for one single rule, we are going to take this result. But then let's say another rule, rule 2, will also have this hypothesis as well. So we are going to merge them. So how will be the merging? Merging would be like this. This one you have seen in ISP 542 as well, right? So for example, if your CF is more than 0, both are more than 0, this is the formula. CF1 plus CF2 times 1 minus CF1. If one of the CF for rule 1, for example, you have negative or less than 0, and another one would be less than 0 as well, so you are going to consider this rule. What about if you have, oh okay, I think this is not correct, this is must be more than one is positive, one is negative, sorry, yeah. Okay, so this is when you have both negative, negative, this is negative, positive, this is positive and positive. Okay, the only differences is when this one is this one, and if you have positive and negative, the formula is totally different. So let us take a look at the question here. Suppose the knowledge base consists of the following rule. If A is X, then C is Z with a CF of CF 0.8. Rule 2, if B is Y, then C is Z as well. So these two hypotheses is the same, right? But then they have different CF value. So that is why we have to take a look at this formula here. So for example here, you have this rule 2 rule. Both of them have positive CF in the hypothesis. So AX is X, A is X and C is Z with CF 0.8. B is Y, C is Z with CF 0.6. So these two is positive. So what about our formula? So we are going to use this formula, right? 1 minus CF here. So we assume that CFE1 is 1 and CFE2 is 1. Okay, so this will be our calculation. So CFE times CF1 would be 1 times, okay, so this is 1.0 and this is 1.0 as well. So times this one. So CF for hypothesis or rule number 1 would be 1 times 0.8. For rule number 2, 1 times 0.6 is equal to 0.6 here, okay? So both of them are positive. So when both of them are positive, you have to take a look at this formula. Okay, 0.8 plus 0.6 times, okay, 1 minus 0.8. CF1 equal to 0.92. What about if you have one CF is positive, another CF is negative? So you have to use the positive negative formula. So the answer would be 0.5. If you got the negative 1, both of them negative, when you calculate the CF of both of them is negative here, okay, you are going to use a formula that is 1 plus CF. So this would be the calculation and the answer here. So you have another question here, so you can try it on your own. So by using the combining, for example, you have positive and positive here, so you are going to use this formula. So certainty factor theory provides a practical alternative to Bayesian reasoning because the heuristic manner of combining certainty factor is different from manner in which they would combine in probability. So, but then certainty factor theory is not mathematically pure, but it mimic the process of human expert, just like we did in fuzzy logic. So probabilistic theory is the oldest and the best established technique when we are going to deal with inexact knowledge and also random data. So it works well in such area as forecasting and planning, where statistical data, usually it being used in statistical data, is usually available and accurate probability statement can be made. However, if these two cannot be made, we are going to use we can use uncertainty factor and also fuzzy logic. So this is the differences between Bayesian reasoning and certainty factor. In Bayesian reasoning, the probability theory, is it the same? But then in certainty factor, it lacks of the mathematical correctness because it used the expert knowledge. But then it outperformed the subjective Bayesian reasoning in terms of diagnostic, or particularly when we have dealing with medical area. Certainty factor are used if the probabilities are not known, are too difficult or expensive to obtain, meaning that our data is quite imprecise or vague. And the certainty factor approach will provide a better explanation of the control flow. So this is the exercise. You can take a look at the exercise here. Right. The conclusion is there are situations in real life when one has to deal or reason with vague, insufficient, or imprecise information to come to a rational decision. So any software or software tool developed for assisting people in assist their decision making needs to take account the uncertainty nature of information. So we have identified the potential sources, the nature of uncertainty in information, and also a common approach for managing uncertainty in expert system, whereby we can use fuzzy logic, we also can use Bayesian reasoning, and also certainty factor. So I know that fuzzy is quite fuzzy, and you think that it is still fuzzy, right? So you can try to do the final year question. You can try them quite few times so that you can be trained of the trend of the final year question and how the answer should be answered, okay, how the question should be answered. So that's it. If you have any question, you can ask me. Thank you everyone. Assalamualaikum and good luck.